What if you could build your own marine computer for a fraction of what the big brands charge? This is the D3N1. It's open source, fully customizable, runs D3K OS, compatible with OpenPlotter and Signal-K, and you can build it in about an hour. Let me show you how. Here's everything you need. You've got two build paths. Path A, the Pi 4B build. A Raspberry Pi 4B with 8 gigs of RAM, a 128 gig SD card, the PiCAN M with SMPS. That handles your power conversion, a heatsink with fan, a GPO extender, an IP67 NMEA enclosure, and an Anker S330 speaker for audio alerts. Path B, the Pi 5 build. Same lineup, but you want the PiCAN M without SMPS. Instead, you'll add a separate 12-volt to 5-volt buck converter, because the Pi 5 draws more current than the onboard SMPS can deliver. Both paths you'll also want a USB GPS, a USB AIS receiver, a USB hub for expansion, a 10.1-inch or larger touchscreen, minimum 1000 nits so you can actually see it in sunlight, a micro HDMI cable, an NMEA 2000T connector, optional backbone, and power cables for the Pi and monitor. Now, two important additions. If your boat is older, year 2000 or earlier, your engine gauges are probably analog. You'll need a CX5106 engine gateway to digitize those signals and put them on the NMEA 2000 network. Modern boats may already have this built in. And if you want marine vision, onboard camera feeds right in D3K OS. You'll need a 5-port PoE switch, a 12-volt to 54-volt DC converter to power it, Realink cameras. I'm using an RLC 510A on the bow and an RLC 820A on the stern, plus outdoor-rated Ethernet patch cables. Quick heads up, if you're running a Pi 5, don't skip the buck converter. The SMPS on the PiCAN M can't handle the current. Step 1, software. Download D3K OS from the project site. Flash it onto your 128 gig SD card using Raspberry Pi Imager and slot it into your Pi. That's your operating system done. See video 2, installing D3K OS image. Peel stick press. Heatsink on. GPO extender goes on next. This gives you the clearance you need for the PiCAN M to sit on top. Now the PiCAN M drops right on. This is your NMEA 2000 gateway. It's what lets D3K OS talk to every sensor and instrument on your boat. Plug in your USB GPS, your AIS receiver, whatever you're running. If you need more ports, add a USB hub. Everything goes into the IP67 enclosure. Use the cable glands for your connections and twist ties to keep it clean inside. This box keeps salt spray and moisture out. For the Pi 4B, the PiCAN M built-in SMPS handles your power. Just connect to your 12-volt system. Running a Pi 5. Wire your buck converter to the boat battery, step it down to 5 volts, and power the Pi through USB-C. Mount your touchscreen. I'm using a 10.1-inch, 1000 nit panel so you can actually see it in direct sunlight. Micro HDMI from the Pi to the screen. Power the monitor from your 12-volt system. Then connect the PiCAN M to your NMEA 2000 backbone with a T connector. If you don't have a backbone yet, you'll need one, plus terminators on each end. Got an older boat? Your engine gauges are probably analog: RPM, temp, oil pressure, fuel. The CX5106 gateway digitizes all of that and puts it right on the NMEA 2000 network. Wire the harness to your engine senders, connect the output to your backbone with a T connector, and now D3K OS can read every engine parameter in real time. If your boat is 2001 or newer, you might already have digital engine data. Check before you buy. Marine vision is where it gets really cool. Start with a 12-volt to 54-volt DC converter that powers your PoE switch from the boat's battery system. Connect two Realink cameras. I've got the RLC 510A on the bow and the RLC 820A on the stern. Run outdoor rated Ethernet to the PoE switch and connect the switch to your Pi. The PoE switch powers the cameras and handles the network. One cable per camera, no separate power runs. Fire up Marine Vision in D3K OS, and you've got live camera feeds right on your Helm display. Bow stern, wherever you need eyes. D3K OS is live. You've got your charts, your engine data, your GPS, your AIS, live camera feeds, all running on open-source hardware you built yourself. Total cost: a fraction of a proprietary chart plotter. Total satisfaction: priceless. This is the D3N1. Build yours. The links to parts and the full build guide are in the description. Subscribe for more open-source marine tech.